Well, hi, and thanks for joining me here in my shop. I'm going to start the alignment process on this radio. Trying to do a careful job at this point and really get the alignment done right. So the very first step on these radios is to check the position of the big tuning wheel on the shaft, and never had a radio start out wrong until this one. So the way this alignment works, since the glass scale is still back in the cabinet and isn't here with the radio, I can't tell from looking at the front where the radio's tuned. So on these radios, a paper scale is attached to the back of the big tuning wheel here, and if you look, you can see I have a camera positioned back here to look up at it. I'll just show you what that looks like briefly. Okay, so as I tune the radio, you see the big wheel turn. Up at the top there, you can see what looks like a pointer hanging down. Let's see, it'll be pointing right at the 10 line right now. That's nothing more than a piece of wire I've attached to the radio to point down here, but I haven't positioned it correctly yet. So the first stage on this alignment is to rotate the capacitor all the way to the end. That's the end. And then the 0 point on the scale should be vertically directly above the shaft. Okay, you can imagine where the shaft is. The shaft. It's a little hard for me to point at it, but just to the left of the line of screws on top of the capacitor. I would say having the 0 point, and here's another thing too. Well, what exactly is 0? This looks like 0. See where the pointer is pointing at the rivet? The rivet is right on the 0 mark. The scale goes past a little ways. To me, that's, am I reading this wrong? 20, 10, no. To me, that last part is -5. 0 would be here. So when I turn the capacitor to its limit, I think this should be sitting here. Right, I'd say about there. But it's not. It's sitting here. So I'm already paralyzed. I'm paralyzed already. I've almost never had a radio where, in fact, I don't know if I ever have had a radio where I've had to relocate this wheel. You know, and as a guess, I would say it's been zeroed up on the -5 line. Let's read the instructions and see very carefully what it says, because maybe it's worded in some tricky fashion. So this is the alignment procedure. When you look at one of these alignment procedures, it's good to scan all the way through the process right to the end to see if there aren't some notes down here that might be hidden a little bit. So I have read through all these. These are not critical for what I'm doing right now, so we don't have to worry about that. There's something up here that is. So we just whip through these quickly. Cathode ray alignment's preferred. Output meter alignment can be done. Make sure the volume control is maximum if you're going to do that from the voice coil. Test oscillator. You know, back in the day, nobody had a test oscillator that was that precise, or as we have today, digital frequency counters that are absolutely precise. So a lot of trick with setting the test oscillator correctly. We won't worry about that. And this is just an instruction to keep the input as low as possible, to keep the AVC action as low as possible. It just makes it much easier to align the radio. Here we are. This is the part we got to read here. Calibration scale on indicator drive cord drum. So they call that big wheel, I call the big wheel, they call it the drive cord drum, or the indicator drive cord drum. Because there's 2 drive cords in here in this radio. There's a band drive cord. The tuning dial is fastened in the cabinet and cannot be used for reference during the alignment. Therefore, a calibration scale is attached to the tuning drum. Oh, now they call it a tuning drum. Okay. The setting of the gain condenser is read on this scale, which is calibrated in degrees. The correct setting of the gain in degrees for each alignment frequency is given in the alignment table. If we look down at the alignment table, here's the degrees here, 149, 73, 73, etc. As the first step in RF alignment, check the position of the drum. The 0% mark on the drum scale must be vertical and directly over the center of the shaft of the tuning drum when the plates are fully meshed. The drum is held to the shaft by means of 2 set screws, which must be tightened securely when the drum is in the correct position. Yeah, you'd want to tighten those things a lot because there's quite a bit of leverage on that large drum. A pointer for calibration scale. Improvise a pointer for the calibration scale by fastening a piece of wire to the chassis and bending the wire so it points to the 0% mark on the calibration scale when the plates are fully meshed. So I think what I'm going to do first, I'm going to move that calibration scale pointer that I put in so it's in the correct spot regardless of what it shows on the scale. I can do that visually by looking with my eyes. I guess most things are visual are done with your eyes. And then we can turn the scale and see where the 0 mark comes up in reference to the pointer. The pointer now being in the correct 0 position, aligned above the center shaft. That's how I'm going to do it. Okay, let's see if we can swing this all the way around. So there's the 2 set screws. These are square-headed. It's pretty awkward for me to do this from here. It's extremely awkward. Basically, I'm having a hard time looking up. I have to flip the whole radio over and look from the back with my own eyes. I think it's the only way I can do it accurately. Son of a gun. Son of a gun. About the camera right now. Swing this around. Okay, maybe this camera's going to get a look at it too from back here. So I get a little closer here. Okay. So the shaft is marked by this screw. This screw. This screw is the shaft. So this is what needs to line up across here with the 0 mark. Let me put this into a 0 position here. That's the 0 position for sure. And I'm looking right over the top of the camera. I'll just look through the camera. Everything is level here. What if I hang a plumb wire, a plumb string down, and what have I got that can be a plumb string right away? Nothing. I need something that'll hang down nice and straight. So I got to find something to use as a plumb line to really clarify this. Okay, so I've arranged a plumb bob. This is a plumb line here. The string is straight down. And maybe if we look from over here, you might get a better impression now. Of course, the question is the whole radio level? is my bench way off here? Oh, yeah. Somewhere I have a level. It's pretty hard for me to believe this is not level. Pretty hard. Okay, so what do we see now? If we look in there, it's not that it needs to be in the same line as the string. It needs to be parallel to the string. Now this is the capacitor completely completely done. See, that's not quite parallel. Parallel would be, I'm doing this with my own eyeball up here, that would be parallel. So conceivably, if that line is straight up and down, then it must be directly above the shaft. And let me just line the string up here. So if you look at the string should be pointing right down to the shaft, which it is. That's the spot where it's supposed to be. Now, how am I going to manage to... Well, what I'll have to do is loosen this off, and then put it in its proper position, because it's going to get messed up while I loosen it off. And then use the plumb line again. See how all that goes. Get my big square pliers here. You have to rotate this thing to get at these anyway. Oh. No. Okay. It's a little tough. There we go. It's loose on the shaft, is it? No, it's still tight. I suppose in some sense this is kind of like a micro adjustment that maybe really doesn't mean much in the end. Oh boy, I can't get at it. That's got to be loose. Feel loose. Let's try these. Yeah, these aren't going to work. These are the best. This is the best tool I've got here. I don't think it's going to fit in there and open up. What about putting some kind of socket on there that might just happen to grip it, even though it's square? Might have something. Not quite. So close. So close. Something slightly bigger than that. I don't think so. There's the same size. There we go. There it goes there. Now it's okay. So we'll leave the tool on it there. This is not the easiest thing to do because so much power has to be applied, you know, when you're tightening it up and that. And during that power application, things can move. Get this lined up again. Okay, now the capacitor has to be all the way. That in itself is a little tricky to do now that the... Okay, that's all the way. Now I'll line up this. So I'm going to do it with my eyes here. Far. Pretty vertical with the plumb line. It seems to be just dead center above the shaft. I mean, how much better can I get it? That's got to be it. Just a couple of degrees here that we're dealing with. I'm trying to lock this on without moving it. Okay. And let me put it bigger. So I'm going to power up my wrench here. This is majorly powering it up. If I can fit this, I can't fit it. Okay, so that didn't power up anything. There we are. This guy get a grip on it here. Okay. Oh, I think that just spun over top of the yeah, we're doing a little damage to something here. Either the tool or the... Oh, looks like my tool must have took a beating on that. I think we got it though. Let's tighten the other one now. I can get at that one with the proper tool, or a better tool. Oh, what just happened there? I saw this wheel move. Tighten her anyway. Okay, let's check this baby out and see if I did anything. So I'm looking at it. It looks great now. Now I don't feel the disturbed sense that it's aligned on this wrong spot. I think it looks great. I think I got it. What? See, the problem here is if this isn't exactly right, then the radio is not going to align very well, and the pointer is not going to meet up with the numbers on the dial properly. I mean, that's a big challenge to begin with these radios. And so you would force it to line up during the alignment process, but then you might have some problems with it, the pointer being correct all the way across the dial. What do you want there, buddy? Hey, you want to go watch TV with me? We're going to go watch some more of the Watergate here. Okay, so despite the fact that 24 hours went by because I was glued to the TV all day yesterday watching the current Watergate hearings going on, and so I'm only back in here the next day, but I have spent quite a bit of time getting this all set up so we can do the alignment and track all the stuff that's going on. So I'm just going to go over the equipment layout here, and then we'll change the camera views a little bit and then carry on with the work itself. But first I should really probably just turn this guy on and get him warming up. Let's do that. I think everything is okay. Okay, just give me a moment. Dim bulbs are showing everything's normal. There we are. The band we're on is the broadcast band, band A. The loop antenna is still connected and hanging up here. We won't listen to that for now. So the first step in the alignment is to align the B band, which is a shortwave band that runs, where does it run? It runs from about 2 megahertz to 7 megahertz, and this is going to be done at 6.1 megahertz. We just make one adjustment for the 49 meter band, 6.1 megahertz. So I have the signal generator running here, and the frequency it's running on is up here. It might be a little hard to see in the camera. So I'll set that to 6.1. Okay, now, so I'll give you a chance to see my different camera arrangements here. So 6.1 megahertz is the same as 149 degrees on this dial at the back here. So we're going to flip to another camera I have set up right inside the radio to see that dial. And this pointer should be zeroed right now. So let me just do a little calibration here. There we are. So this is supposed to be set to, oh wait a minute, this is an oscillator adjustment. Okay, I just wasn't expecting that. Here we go, up to 149 degrees. Oh no. What happened there? What just happened there? Oh, for crying out loud, of all the goofy things to have happen. You know, I've spent a long time getting this guy set up, only to have this happen. I just can't believe it. Let's see if I can just get it on camera here. All the things. I don't know if you can see it. Here's my pointer, very carefully engineered pointer. There's a set screw right there. As I turn the dial, it smashes into my pointer. Oh, for crying out loud. How come I didn't notice that before? I thought I dialed this thing all the way from one end to the other. Okay, so more dial work here. Now the radio's on. Don't forget that, Jim. Oh, this is the stuff I was doing off camera to try to avoid having happen exactly what has happened. So you see I've attached the temporary pointer wire here on the capacitor, which I thought was a good idea. Now let me set this all the way so we can calibrate again. Just trying to trigger the focus on the camera. There we go. We'll try to put this into the correct position. Something's gone wrong with my wire. Oh, for God's sakes. Okay, fashioned a new pointer on there. This one is a steel wire, not a copper wire. It's plenty stiff. It's not going to get knocked off easily. There we go. So, now we have another camera. I have another camera set up, and this one is to watch the AVC voltage. Let's just double check now. This is on the negative setting here, so upscale is a negative reading. Let me tune the radio a little bit. How do you like that? 15-volt scale. Okay, that's pretty convincing that the radio is working. The instructions say in here it says it's better to use a oscillograph to derive a symmetrical curve when you're doing the IF. There's no explanation of how you manage to do that. So I guess try that later. I'm going on the assumption that the IF is tuned up now. I did it once. I think it's probably still okay. That is a bit of an assumption. I'm going to tune the rest of the radio up, then we can always go back and double check the IF afterwards. It's got to be close anyway. So 6100, let me just adjust it over here. Okay, that's going to be very accurately 6100. We're feeding here. Strengthen that up. Of course, we're listening to the broadcast band. That's not where we want to be. The broadcast band gets aligned last on this radio. What we want to be is on B band. Okay, that's B band, and we want to be at 149. I'm going to stop and rearrange my camera so we can see everything all at once. Okay, I think I'm ready now. Let's turn this down a little bit. So what we want to do now is get this to, I think it was 73. Pick up the signal generator at 9.55. Okay, 73. Here we go. Oh, I went right by there. Why no modulation? Oh, it's there. Hear the 1000 hertz tone. Very quietly. Okay, so we want this to actually come out at 73. I'm going to put a little more power here. There. And we got a nice clear signal. See the AVC? No doubt the AVC voltage is working. So I'm watching the meter. I'm looking at the meter pointer on the screen there. And I'm watching with my other eye the way I'm moving the dial. Of course, it's my hand moving it, so I know what I'm doing. But you can watch the other dial. I'm going to move it very, very smoothly. And just watch the ABC. Up, 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 up. Stop. Down, down. Stop. Oh, well, ooh, what was that? So it's not really describing a nice smooth curve. Going back the other way. It's much clearer going that way, but there's really two peaks in there. Does not bode well for the IF. Well, let's carry on here. Oscillator 73. Is that right? For sure, that's what that was. 73. Start here, 31 meter band. First detector. Oh, then antenna, then oscillator last. Well, that's a little different than what it usually is. Let's follow this. So C17 detector. I've got to do the oscillator, really. I think I'd rather do the oscillator first and move this dial pointer to the right place. So that would be L15. L15, let me just look quickly on the diagram here. So L15, it's going to be one of these adjustments in here. L15 is, it's the one I got my finger on. That's L15. 9550. So we want this to be at 73 when we're done. Okay. There we go. I'll go towards 73. No, towards 73. And figure out which way to turn the screwdriver to pick it back up. It's this way. We'll put it right on 73. And we'll max it here. There's another... So when I'm turning the oscillator here, it's very, very similar to just turning the dial, the tuning dial on the front. So I get the same effect. I'm just going to go across the signal and you watch that pointer. Up, 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 up. Oh, down, down, down. Oh, oh, what was that? And if I go the other way, it looks like a different pattern. Let me come back. I noticed this the last time too. Come back. Up, up, up. Hold. Up, 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 up. Then down. Wow, it's really not very reassuring here. But let's carry on. So we want this to be maxed at 73. There we are. Now the next two things, I'm doing them out of order here, doing them in my order, C17 and C8. Check the 0 on the pointer. 0 is still 0. 73 is where we were working. 73. Radio on. Okay, did we get it tuned right to 73? Let's tune the radio a little bit and watch the ABC. Down and down. So dead on. Right on the money. Now we're going to try to do the detector. Don't grab the business end of your tools. For the longest time I thought these worked by just turning them. No, they don't work by just turning them. You kind of turn them to get them to travel, but it's really pushing them up and down. And we got to watch that meter really carefully while I do this. Downwards first. No, that's not helping. Okay, now upwards. Upwards. Upwards first. There we go. Up, up, up. Kind of bumping the tube there. How far up can you pull this? Oop. Oh, there we are. Okay, back down, right around 9, I think. Oh. A lot of these controls, just applying pressure causes a change, and then when you release the pressure, it goes back to where it was. It's kind of like a backlash kind of deal here. So we're trying to get it to stop on 9, I thought. Maybe not. Maybe we're trying to get it to stop on. Yeah, every time I push down, I think that's about as high as it's going to get. Oh my gosh. It's very inconsistent behavior. I just shoved it right to the bottom and look, it's coming up again. What's happening here? Okay, let's pull it up. There. I got it to 9. Okay, so that's peaked up the detector circuits on this band, and the next one to do is C8. C8. Which one is C8? C8. Let me just take a peek, and we'll find out. C8. Just there we are. C8 is the other one. The other guy. Done at the same frequency. This is the antenna adjustment. So that's this one up here. The one we were loosening off. Okay. And watching the meter. Gonna hold the radio down so I'm not pulling up so hard. Ooh, what's it doing there? Okay, up first. Okay, up is down. Let's go down. Oop, a little too far. Up. I saw about 10.4 there. Yeah, right up in there. There we go. Now if I tighten these guys down, it'll cause an adjustment change. I'm pretty sure. So I'm going to leave them as they are. They're not going anywhere. They're not going to wander off. That's it for the 31 meter band. Bravo. Now we're going to go up to the 25 meter band, 11.8 megacycles. Let's go to the 25 meter band. It says 25 in the little window. There's that tone again. It's very quiet, but I'm sure you can hear it. It's always present in this radio. What's that say? That says something in the IF? I don't know. Okay, now for this one, for this band, the frequency was 11.8 megacycles. Okay, let's go up to 11.8 megacycles here. Pretty close. Oh, wait a minute, why would it be coming in? Is it also at 73 degrees? No, this is done at 99 degrees. And where are we? We're still at 73. How come I heard that? Okay, we'll go up to 99. There it is. But it's supposed to be here. Yeah, I think it's a single adjustment for this band. It's just the oscillator adjustment L14. L14. Get a tool here to do this. L14 would be one of these. It's hard for you to see it on this radio. There's a whole pile of adjustments here. They're in the back of the radio here. So when the radio's in the cabinet, these are easily accessible. You can reach in and do this while the radio's in the cabinet. And then you can compare it against the dial glass properly. But at this point, we just have to settle for the scale on the back of the wheel. And which one is it again? It is 11800 L14. It's this guy right here. Right where I'm gonna bump into the camera that's set up here. Yikes. Okay, we're watching the. So the objective here is to move this tuning until we see, what do we see up there? 99. Okay, go towards it. And we'll find it. Ooh, that doesn't sound right. It's okay, it's okay. Sounds fine. 99. Looks like I kind of went past it a bit. Okay, on the meter. So this is going to make the dial accurate. This isn't making the radio more sensitive. You know, it might seem that way. I'm just tuning it in. That's really what's going on here. That's about it. A little round of applause for that band. Next band is the 19 meter band, 15.2 megacycles. Okay, let's flip the radio to 19. Definitely 19. Move the frequency generator. The big generator. 11.8 megacycles. Oh, that's where it is. What am I doing? Next one up, 15.2. 15.2. That's good. 15.2. And L13. L13 will be one of these guys again. Which one is it? L13 is inboard corner. So one of the things about alignment is when you get towards the end of doing the alignment, if you make a little mistake and turn the wrong control, hit start over again time. There we are. We're on 99. How come we have no signal? What did I do here? Did I do something dumb? Oh, wait a minute. You know what we're done? What have we done here? We should be at, oh, yeah, 94. Should be 94. I got that wrong. Oh, I made a bad mistake there. 94. Not that far away. Why are we not hearing it? Let's give it a big whack of power here. And this is supposed to be 15.2. There it is. Oh, it's barely coming through. I am pumping one heck of a signal into the antenna. By the way, you can see one of the steps I didn't really mention that you have to take when you're doing this with a signal generator. The output of my signal generator is 50 ohms. So if I hook it up to the antenna, it's like putting a 50 ohm resistor on here. That's quite different from what is usually on these terminals, which is some kind of open wire. It would look like 200, 300 ohms depending upon where you're tuned. So to bring this into a better similarity to a regular antenna, I had this resistor installed here. And it's a couple hundred ohms. That's what's going on. Now, question is, why aren't we hearing this? So the band number, oh, you know what it is? Bad band switch again. It's 19. Let's try that. Oh yeah, I heard it. So we're doing, so clearly the band switch is dirty. It's in there somewhere. There it is. There it is. Now we're cooking. Okay, so we want to move it from where it is up to 99, right? Double checking. I never rely on my memory anymore. So I want to get this to 99, and the frequency was low on here. Okay, there we are. Now we want to peak this up at 99, and we want, which adjustment? 25 L14. Why does that sound so familiar? So L14. Okay, I see what's going on here. L13. What's going on in my head? L13. That's what I see. I see what's going on. L13. 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 Right. Been in here a little too long today. Lots of time spent before I turned on the cameras here. Okay, so we want to get to 99 with this. This is the way we want to do it. So we go in the direction that we want to go. Let me try to bring it back. Okay, I know which way I'm going now. Okay, 99. Certainly the ABC is really active here. Because you have a powerful signal coming in. So this signal right now would represent a strong signal on an antenna, and it's not very strong on the radio. Just an oscillator adjustment here, nothing else. When I go to the highest band, there's a bunch of stuff to adjust. 4 adjustments. I don't think I can do any better on this band.